Let's implement a smart static array. So if you'll remember from other programming classes, when you're using an array, there's some sort of max size for a static array. You have to know this at compile time. And if you go outside of bounds of the array, such as accessing a negative number, or accessing the element 5, or the element greater than 5, these will all cause a segfault. So 5 is invalid because when we have 5 items, we have 0, 1, 2, 3, and 4 as the indices. So the index 5 is actually the 6th item, and that's not valid. We haven't allocated memory for that. We only have memory for the first 5 items. So in our smart static array, we'll have our basic array functionality, so we want to be able to add items to it. I want to be able to remove items from it, access items in the array, and then also just some helper functions like, is the array full? Is it empty? What is the size? And so we have all these functions. Does the array contain this item? How many items of this type does it contain? I mean, like, if you inserted ABCD, ABCD, ABCD a bunch of times, it would count the amount of A's. And then we have some helper functions here, which will help out with pushing at the front or in the middle of the array, and removing items at the front or the middle of the array. So here we have push back, where we add to the end of the array, push front to add at the beginning of the array, insert to insert in the middle, and so on. So let me open up my thing again. If we have an array, we have several items at index 0, 1, 2, 3, and 4. So this would be the front, and this would be the back. And let's say M item count at this point. Let's say it's 0, so there's nothing in here at first. But when we add one item, this gets incremented to 1. When we add our second item, this gets incremented to 2, and so on. So first off, we want to make sure that the item count starts at 0. So I'm going to replace this with item count is 0. Now, I have some tests here to help me test the functionality so I don't have to manually check everything. At the moment, it won't run through all the tests because I have a lot of exceptions set up, because these are all not implemented, so it hits those exceptions and stops. But we can at least see that now that I've put the item count to 1, the list, this passes, because it's checking to see if the list has a size when it's first created, and it does. So if this had been set to nothing and we ran the test, it would run and then it would fail because we don't know what the item count is set to by default. It's probably just some sort of garbage. And then, well, the rest of the functions, the rest of the tests don't work because we have those exceptions. So at the very basic part, we need to have item count as 0. Returning size should be pretty easy. We can just return what that item count is. Is empty, we return whether M item count is equal to 0. If it is, then it is empty. We return true. If not, we return false. Is full, since we're working with a static array here, we have this static array with a maximum size up here. If we were working with a dynamic array, we wouldn't have a max size. We would have a size of the array and need to resize if we hit that, but there would be no maximum size. You could, as long as you have memory, you could keep increasing the size of your array. But we're working with a static array just as a way to show some edge cases you might need to be aware of if working with static arrays. So here we can return if the item count, M item count, is equal to the array size. So if that is true, it will return true, and it will be full. Okay. I don't know what my next set of tests are. We have test pushback, so that's not going to run those tests until I implement some of these. So the easiest ones to implement will be pushback, popback, and then the get functions will be pretty easy to implement as well. And then we can implement some of these helpers here in a moment. So for pushback, first we only need to make sure that the array is not full. If it's full, we can't add any more items to it. So we'll say if is full, we'll throw an exception. We can't add any more items, it's full. Otherwise, all we're doing is going to add an item to where the current next available space is and increment the item count. So for example, again, we start with item count as 0, and we know that the next item will go here. And we'll put it there, increment item count. Now that will be 1. And we'll know next time we go to push something that it should go at 1. Then that gets incremented to 2. And the next time we add something, it goes to 2, and so on. Okay, so we can't test pushback right at this instant. We need to implement the getBack function as well, which is what my test uses to make sure that it's pushing the right values in there. So for getBack, we just need to return that item at the back of the list. So again, if we have, let's say, A, B, and C, our item count is going to be 3, so the next item we have access to is number 2, the item count minus 1. So here, let's say if item count is 0, we're going to return null pointer in this case. I'm returning pointers to the elements, but there are different ways you could design this as well. Otherwise, if we have that many items, we can return the array at item count minus 1 and return that data. So let's see if that, cannot convert. Oh, this, has to be the address. We run, and now my pushback functions are running, and those are both passing. Popback isn't running because we haven't implemented that yet, but that will be an easy one to also implement. So for popback, if the item count is 0, we don't need to do anything. But if the item count is greater than 0, then we have items to remove. If we're looking at this, and we have an item count of 3, and we want to pop back, we don't actually need to clear the space here. All we have to do is say, hey, item count is 2 now, so 0 through 1 are valid indexes, and this one will just be replaced next time we do a push. So if we do push Z, then it will say, hey, item count is 2, insert the next item at position 2, and it will overwrite it. So we don't really need to do any hard work. All we gotta do is decrement the item count. Okay, let's go ahead and see if that test runs now. So our popback runs, it checks it, and it passes. Now the get function, the first one passes, but there are several tests per function in some cases. And let's see, where is get? So get front, get back, those are all going to be pretty easy. Let's just implement those right now. For get front, we're just returning the item at position 0 if there is an item. And then for get, we'll have that, but we also need to make sure that we don't have an invalid index. So if the item count is equal to 0, or at index is less than 0, which would be invalid, or at index is greater than or equal to the item count. So actually, if the item count were 0, I think that would check for that as well. Return null pointer in that case. Otherwise, if we have a valid index, we can just return the item at that index. So go ahead and run again. We have get, okay, that's still not passing everything. Let's look at the get function in the tester. So get implementation, we need push front and push back because it's going to test both of these. So we have our get functions. Those will be tested in a moment. Push front is the first more tricky item we can test out. So when we are pushing to the front of a list, we will essentially need to move everything else over. So we have ABC here. Let's say we're pushing to the front of the list. We're going to put Z here. So what we're going to have to do is move C over here. This will be C. We'll move B over here. So let me try to clean this up a little bit. And we'll move A over here. And A goes there. And then we'll replace this A with our new Z. So that's our push front. Now when we do this, we have to start from number 3 and go that way in our for loop. So let me try to show you this again, because if we start at 0 and copy 0 over to 1, then we'll have A here. Then when we try to copy 1 over to 2, then we'll have A again. So we have to start from the opposite end. We have to say, hey, we're going to take 3, we're going to move 2 to 3 and put the C there. We're going to move 1 to 2 and put the B over here. Oops. And we're going to go to 1 and move the 0 to 1. So over here, let's look at push front. I actually have a helper function for us called shift right. So at the place where we're going to add our new item, which is 0, we'll want to shift everything over to the right and then add our new item here. So we'll have M array at position 0 will be our new item, and we need to increment our item count. Now we also need to check for errors. So in the case where the array is full, if is full, we're going to throw an exception. Okay, so this shift right function is up here. It's a private function. Outside users don't need to use it. They don't need to know about how this works. But internally, we might need it whenever we're inserting something in the middle of other elements or when we're adding something to the beginning of the list. So for shift right, again, we have to start at I equals the M item count. And we'll keep going until we hit that at index and decrement each time. We're going to go from the end to the front or to whatever index we're going to. And we'll say the array at this position is going to be the array at I minus 1. So again, we're going to say the I at, like say I is 3, 3 is equal to the item at 2, 2 is equal to the item at 1, and so on, so we aren't overwriting values. And I'm not adding any error checking here because this is an internal function. Hopefully the functions that call shift right and shift left will do their error checking ahead of time. So these should ideally just kind of be there to aid the other functions. So let's see, we implemented push front. Let's see if those other functions finish. We have get, push front 3 items, push back 3 items, those both pass. We have get back, that one passed. Get front, that one passed. The size function does complete, so now it aborts at get count of. But look, we have size is passing, testing is empty passes, testing is full passes, get count of we have not implemented yet. So in its test, it's pushing back the word Mississippi, and then it's checking to see how many I's are in there, that word. So let's look at that function. Alright, so for get count of, we basically just need to iterate through the array and count how many times we see this item. So I'm going to create a counter and set it to 0. For int I is 0, and we're going until item count. If the array at that position, that element, is equal to the item, we're going to increment the counter. And at the end of the loop, once we're all done, we're going to return whatever that counter's value was. Contains will actually be pretty similar, so we can kind of copy it, not completely. We'll copy this for loop here, and it just returns true if it finds that item. And it will return false if it does not find the item. Now a common error is for students to do this, which is wrong. This will only check the item at position 0 and return either true or false immediately. What you want to do is loop through the entire loop if you get done with that loop and the item is not found, i.e. return true never occurs, we know that we haven't found the item, so we return false. So we have both of those working. Let's run the tests. And this is all stopping at each of the runtime exceptions. But now our getCountOf passes and our contain passes. Clear hasn't been implemented, so that's what we can look at next. Clear, that should be pretty easy. Again, with the lazy deletion, we can just say the item count is equal to 0. So if we have a bunch of items, so let's say we have 3 items, if we change this item count to 0, then anytime we go to add a new item, we will just replace each of these values as needed. So no reason to clear out those values or anything, they'll be replaced as needed. We'll just set item count to 0. Okay, now we have most of these implemented. We haven't done insert yet. So that will be similar to how we have push front, but we'll have to do some extra error checking. So if the array is full, we don't want to do anything. I'm just going to say this is full. We also don't want to allow for any invalid indices. So if the at index is less than 0 or the at index is greater than or equal to the item count, you can throw an out of range error and just say invalid index. We also don't want to reinvent the wheel, so let's say the user wants to add at index 0. That's essentially a push front, so we'll just call push front instead. And if the user wants to add an item at the item count, that's essentially push back, so we'll do push back with that item. Otherwise, if it's none of these other cases, we are inserting somewhere in the middle of the list. So we'll shift right at that index, and then add our item at that position, and increment the item count. So looking at this, let's say we have several items, A, B, and C. We want to insert Z at position 1. So we have to shift everything right. We move C over to 3. We move B over to 2. And then we have enough space and put our Z here. So we use that shift right function again. And that should be okay. I don't know if that's the next thing that gets tested in the tests list. We'll see. Okay, so I'm getting an out of range error in the test for insert. Let's look at that really quick. Did I make a mistake in the insert function or in the test? So 2 of the tests pass, but it looks like the third test isn't working. Oh, I see. That's because I have this here. This should actually be if we're inserting at something greater than item count, then it's invalid. But if we're inserting at the item count, that's a push back. So that should be okay now. Let's go ahead and run this. Alright, now that I fixed that test, insert passes. Shift left isn't passing, but we haven't implemented that one yet. So shift left is another helper function. It'll be used for when we remove items. So let's go back to this state. Let's say we want to remove the item B. We want to remove the item at number 1. Well, we don't want to leave this gap here. You could if you were designing it that way, but that's not how we're designing this. We want to make sure that everything is contiguous. So for removing B, we want to actually just move C backwards over it and then decrement the item count. So it's okay that C is here because these will be the valid elements because we only have 2 items now. But we'll need to use a shift left function to overwrite what we're going to remove. So for shift left, we'll start at whatever index was passed in. We'll go until we hit the item count and increment each time. The item at the current position will be the item that is to its side. So before we run those tests again, let's go ahead and look at the functions to remove items. We have pop front, remove item, remove index. And I think these are the last functions left. So if we're popping the item in the front, really all we need to do is say, hey, move B over here, move C over here, overwrite this A, get rid of it. So we'll move B here and C here. So we can say, oops. So first we want to make sure if the item count is greater than 0, we're going to do this. Otherwise, there's no reason. So we're going to say if the item count is greater than 0, we're going to shift everything left. So we'll overwrite the item at position 0 and decrement our item count. And for remove item, it will also be similar, or not remove item at index. First we have to make sure the index is valid, so if at index is less than 0, or at index is greater than or equal to m item count, we're going to say this is out of range. Otherwise, we will shift left at that index and decrement the item count. Okay, let's go ahead and run these tests. Keep going. Okay, we're hitting the exception for remove item, but we haven't implemented that yet. So remove index, these are all passing. It removes items 0, 1, and 2 in different tests to make sure those work. Pop front is passing, shift left is passing. So remove item, we'll do that one next. This is a function where anytime we have an instance of some duplicate items, we'll remove all of those. So let's say we have, I inserted Mississippi as the test data, but we'll just do this. So let's say we are going to erase all i's. What this will look like afterwards will be MSS, because we don't want any gaps in our array, and then these will just be whatever. So we'll need to essentially shift left here and shift left here if there are any other items on the sides. So for remove item, we're going to start at the end of the array and increment until we hit 0, or sorry, decrement until we hit 0. And if the item at this position is what we're looking for, we're going to shift left and overwrite it with its neighbors to the right, and decrement item count each time. So this will remove items every time it finds one of these, but we have to start at the end and go towards the beginning. Okay, so the execution finished. Let's look at the test results here. So these are all green. Everything ended up passing. 19 test sets ran, 19 test sets passed. So that's how you would implement each of these functions using a static array. Now, if we were working with a dynamic array, there would be some changes. We wouldn't have a max array size, so we wouldn't need to check if is full. We would just get rid of that function and the tests associated with it. And then there are also some tests in there that makes sure you can't go past the array size. So in that case, any checks for max item count would be removed. But yeah, that's how you implement just kind of a simple, smart static array, and using some exceptions in there, checking for errors, and having some helper functions.